The hydraulic power steering pump is responsible for providing enough pressure for the hydraulic power assist system for the power steering. As we covered in hydraulic brake boosters, these can also supply pressure from the power steering system and loop it through the brake booster in order to achieve hydro boost pressure on a hydro boost system. So maybe on a diesel that doesn't have vacuum, or on some other vehicle where the clearance is an issue and running fluid up to the booster is going to be more practical than a vacuum type of booster. Now, power steering pumps put out a significant amount of pressure. Most hydraulic power steering pumps are going to output about 1500 to 1800 psi of pressure for the system to use as power assist to steer. That's a pretty significant amount of pressure coming out of a little pump like this. So how does it build that pressure? Well, let's look at the construction of this pump in particular. This piece down here is the pump body, okay? It has an input shaft on it that is engaged to a pulley and oftentimes driven by a belt. An electric motor can drive a mechanical power steering pump to pump fluid. So you may find that as well. Can't rule anything out. So this is the input shaft to the pump. So what's happening inside the pump body itself? Inside the pump is an impeller. And this impeller has little vanes in it. These vanes are little flat pieces of metal that ride in these little slots. So they can stick out or they can ride closer in. And this assembly is splined to the input shaft. This actually has, you can see some splines on the inside there. So as this is spinning, depending on the size of the pulley will depend on the forces acting on this, but the centripetal force is going to force the vanes outward while it's spinning. It's going to spin inside of an elliptical chamber. So kind of an oval shape where there is more of a gap on one end and another end compared to on the sides. So those vanes inside the power steering pump from the impeller are being spun and the force is bringing them outward against the inside of the pump housing. As those vanes are flung outward against this wall, due to a pressure differential created by the movement of the fluid, and it's important that there is zero air in this system, has to be free of all air, only fluid, it's going to allow fluid to come in one side and move it across, and then there will be a restriction on the other side as this is rotating through and the vanes are moving the fluid over. So each vane will be grabbing and trapping fluid and moving it over from the inlet side to the outlet side. And both sides of the pump, both sides are going to be doing this. So we have fluid coming in and fluid going out. We have fluid coming in and fluid going out. This is outputting from two sides of the pump body itself. And because of the RPM that it's spinning at and the way that the vanes are moving, it's going to be able to produce between 1500 and 1800 psi worth of pressure in the power steering fluid. All of that work on the fluid, all that force acting on the fluid and under pressure is going to increase the temperature of the fluid. Depending on the system in the vehicle, a power steering system may include an oil cooler and possibly a filter. On this pump body, the fluid reservoir is this black plastic piece on top. There's a filter screen inside, and you'll notice a little hose connector right here. This just has a barb on the end of it, and a hose fits over it, and a hose clamp fastens it to the reservoir. That is the return line. That's the fluid that's gone through the system under pressure, and when it returns to the reservoir is no longer under pressure. For there to be pressure on a system, the pump needs to provide flow and pump fluid against a restriction. The restriction is what gives us pressure. Inside of the pump body are flow valves and pressure relief valves in case the pressure spikes or in case the pressure output coming from the pump is not needed. So when would that be? Well, when driving straight, for one. When the steering isn't being used, if you're driving straight, there's zero turning left or right, and there's no need for power steering. So the power steering pump is going to continually be circulating the fluid, and the restriction is the steering gear, and the resistance is the tires in contact with the ground with the vehicle weight on it, and all the other components that are moving when you're turning the steering wheel. The slower you're going and the farther you're turning is going to require the most amount of pressure. So our outlet from the pump is going to be a threaded fitting that accepts a rigid line or hose assembly that can hold the pressure. Once that pressurized fluid gets to the restriction or goes through the circuit, through the flow control or the pressure relief valves, its pressure will then be released by the time it gets back to the return circuit and goes into the reservoir. If there was to be pressure put onto this reservoir, this seam would break, the hose on this end would not be able to hold, and the system would not be working. This is an example of a power steering pressure hose off of, I believe it's an early 2000s Jeep Grand Cherokee. Brand new part, never used. Very similar to the brake line construction, we have a flare nut, considerably larger. The diameter of our line is designed to flow a significant amount of fluid under pressure. So just like the brake system, which can operate in excess of 1,000 psi, we have a type of flare on the end here. This would normally have an O-ring resting right here on this side. That O-ring is providing a seal, and the flare nut threads into the port, and the threads in the flare nut are what's supporting the load of that seal. And it's forcing the backside of that flare and that O-ring into the sealing surface, and this gives us our strong connection. So another flare nut pushing on the flare of a hard line. Now these components are on the engine. When we're a belt-driven component from the power steering system, it's mounted to a bracket on the engine, and the serpentine belt is driving it. The engine moves and it has vibrations in relation to the chassis. The chassis is where the power steering gear is going to be located and will require some flexibility to get there. So pressure hose is rated to operate at those high pressures. This is going to be a different type of hose. This will be more of a hydraulic pressure hose than a bulk oil hose that you can get over that you can cut off of a roll. These are attached to the hard lines. There's a barb on the end of the hard line in this. The hose is slipped over that, and then this crimp collar is permanently crimped around the hose. That connection is rated for the pressure of the system. When you're looking for leaks in a system, these are always a good place to look to see if there's a leak occurring where that hose joins the hard line. It's a common spot to find leaks. The other end is also going to have a pressure crimp fitting, crimping the hydraulic pressure rated hose to a hard line, and then that hard line is going to be routed however it needs to be routed to attach to the next component, whether that's the steering gear, the brake booster, wherever this is. It's going to have another flare nut with the threads acting in the port and pushing on the backside of the flare and sealing that line. The pressure side of the hydraulic power steering system is more likely to show a leak at some point, because that is under pressure and it's operating under pressure constantly. The reservoir that contains the fluid isn't always going to be attached to the body of the pump. Sometimes the pump body is located somewhere in the engine compartment that is not feasible to access a fluid reservoir. In a lot of cases, the fluid reservoir will be remote mounted, and it will have lines or a pressure feed line that supplies the pump with fluid so the pump can provide pressure to the system. And then once that pressure has been used and the fluid is no longer under pressure, a separate line will route the fluid back into the reservoir. On a vehicle that has an oil cooler for the power steering system and possibly a filter, if equipped, that filter and the cooler will be located on the low pressure side of the system. If the system were to run a filter and a cooler on the pressure side of the system, that would require the manufacturer to engineer the cooler assembly and the filter assembly to withstand the extreme amount of pressure that the fluid is operating under. So it doesn't make sense from an engineering and cost standpoint to put those on the pressure side of the system. Those will be found after the restriction, so after the steering gear, on the low pressure side before it returns to the reservoir. If air gets introduced into the system, that can happen a couple different ways. The level can become too low in the reservoir due to a leak somewhere, and the pump can start drawing air into the system. This will sound like a whining noise, and many Fords make this noise. Some people joke that it's the Ford supercharger because it almost sounds like a supercharger whine, but not quite as cool because it's a problem. Other times, there could be a faulty seal somewhere on the body. A lot of the times that could be on the input shaft of the pump itself. And due to the pressure differential allowing atmospheric pressure to push fluid into the pump body, that same pressure differential can happen around any of the external seals on the pump assembly. And if that occurs where there is a pressure differential where the pressure outside is greater than the inside, that may introduce air into the system and cause the same whining noise. An air-rated system is not going to be an efficient system, and it may generate more heat and friction due to lack of lubrication. We're going back to Pascal's law. We're trying to distribute even pressure undiminished in all directions in a sealed system. If air gets into this pump, air can be compressed. So that's going to cause the pump to have less resistance, and that air is going to be foamed up. That air is going to be compressed. That's going to generate more heat. There's going to be starvation of fluid to cool and lubricate the friction components and lead to premature wear of the internal parts of the pump body, and the system isn't going to operate correctly. So part of servicing power steering systems, disconnecting lines, removing components, replacing components, a large portion of that service will come down to, in the end, getting the system air free and purging any of the air bubbles out of that system. There are some methods that can be used that we'll go over in lab that clear up the mystery behind that a little bit more. On some vehicles like Subarus, the power steering pump is located up on top of the engine assembly, and the reservoir is remote located and maybe lower than the pump. On these systems, it's pretty common to get that whining aerated fluid noise, and simply detaching the reservoir from the bracket and lifting it higher than the pump is often what's needed in order to get the pump air free and purge the air from the system. As the fluid becomes aerated, those air pockets are going to be obliterated and emulsified into the fluid. That emulsification is going to aerate the fluid, and it'll look kind of foamy or pink. It'll have a foamy characteristic to it. Once the fluid becomes aerated, and that just means once that air pocket has passed through the pump itself, and you hear that little noise, that means your fluid is now aerated, and you have to shut the vehicle off, let those tiny air pockets and air bubbles rise out of the fluid, start, stop, and repeat until all the air is mitigated from the system, and keep topping off the system with the correct fluid. On fluid. Depending on the materials that a manufacturer uses in the power steering system is going to determine what fluid is required for that system. Some fluids are compatible to different manufacturers and different pumps, different systems. Other systems require specific fluid designed only for that system, or maybe a hydraulic oil, mineral oil type of application. Some of the systems may use automatic transmission fluid. Something to think about on the transmission fluid side of things. Automatic transmission fluid operates inside of an automatic transmission, and those are usually reaching maybe peak pressures of about 80 psi. Usually you're going to find between 40 and 60 psi operating inside of an automatic transmission. So think about a fluid that's designed to operate in a system that is reaching about, let's say, tops 80 psi. And you're using that same fluid inside of a power steering pump and system that pressurize that fluid to possibly 1800 psi. Significant difference in pressure under operation. So that fluid's going to break down faster in a power steering system than it would in an automatic transmission. This is why a lot of manufacturers will use a specific type of power steering fluid that's designed to operate and withstand and hold up to the pressures of operation. Servicing these systems, a general service on the fluid, is key for maintenance of the system. And servicing isn't a complete exchange of fluid. When we service power steering fluid on a system, we draw some out of the reservoir while it's running, and before it gets too low, we add fresh fluid in, and we bring that level back up. So we start diluting the old fluid with new fluid. And we continue that process until we go through between 1 to 2 quarts of power steering fluid. And by that time, a large percentage of the old dirty fluid has been removed, and the majority of the new fluid in the system is the new fluid. It's not a 100% exchange of fluid, because the system is continuously circulating while you're introducing and removing, introducing and removing, introducing new, removing old, introducing new, removing old. Some of that new fluid gets mixed in with the old fluid, and that percentage of old fluid diminishes the more times you repeat that process. Maintaining proper fluid level is key on these systems. They don't operate with a lot of fluid volume. So any change in the level of the fluid in the system may have adverse effects if it gets too low on the rest of the system. If the system hasn't been serviced in enough time, then there may be deposits and varnishes and particles that wear from the inside of the components, whether that's from the steering gear or from the inside of the pump body, maybe the booster. As that wear occurs, these particles can get stuck in certain areas and cause valves to stick and cause some issues with the power steering system. So keeping the fluid maintained at a nice, clean condition is going to be a major benefit of a service to keep up on, and not let it get to the point of being damaged and then having to replace or repair the system. Flexible hoses are going to leak. There's no way around it. Eventually that pressure is going to find its way past that pressure crimp fitting, and it's going to leak out, and you'll see wetness on the hose. The difference between a seep and a leak is the formation of a drop or just some wetness. If it's just wet without any sign of dripping anywhere, that's going to be considered a seep. If you see a drop forming down along the line to some lower component, a drip or a drop of oil is going to be considered a leak. So seeping is wetness, an actual drip is a leak. When checking the fluid level, follow manufacturer recommendations on the service procedure for the system and what that level check procedure is supposed to be. Some vehicles, most vehicles I would say, involve checking the level in the reservoir with the engine in the off position. So without the engine running, without the input shaft of the pump running, check the level when it's static and still. Other systems may have you check the fluid level when the engine is running, which would lead to, as the pump is operating, that level may change from an engine off to an engine on and running compared to one that is not. And like I had mentioned earlier, it's entirely possible to come across a system that has an electric motor driving the input shaft on a hydraulic pump. That enables the pump to be located somewhere else rather than on the front of the engine driven by a belt. All right, here we are at the CJ5 again. The power steering pump on this vehicle is located right here. This is the pump reservoir. It's integrated to the pump itself, and then the pump pulley and the serpentine belt running around that. This has a dipstick built into the cap. There's a hot and a cold level. After the system's been operating for a while, the fluid will heat up, and this is where the fluid range should be when it's hot. On the reverse side, this line shows how high the fluid should be when it's cold. Inside you can see the fluid circulating. Might be a little loud under the engine on this one, but it's in a similar location as the Jeep for the power steering pump. They are both Chevys after all. On most systems, when you're checking power steering fluid, most will have you check it with the engine off. Always refer to the service manual for the proper method of checking the fluid. That way you don't measure it incorrectly and overfill or underfill the system. So these caps are usually going to be held under spring pressure, and it requires lining up the grooves, pressing them down, and turning them into position to lock it. Doing this, you may have to do that in order to get the dipstick to the proper depth of the fluid to inspect the level. This is operating at cold at the moment. The system is not heated up, and we're still within the acceptable range. Replace the cap, lock it in place. Leave it looking better than you found it. It was only a matter of time from the time that automobiles were available to the public market until there was a steering assist option available. First introduced as a luxury option and probably on higher end luxury vehicles. For a long time, most vehicles had manual steering, unless the vehicle was big enough and heavy enough to require power assist, and that would make the vehicle more expensive. Now, it's rare to find a vehicle that has manual steering. You can probably still find them, but it's likely to have electronic power steering or hydraulic power steering just standard on the model, from economy all the way up to luxury vehicles and high performance vehicles. Previously, in order to gain leverage on the steering wheels, picture a tractor trailer, semi-truck, or an off-road application like the Jeep. If it didn't have power steering, it would have a really large steering wheel, so your leverage on the steering column into the steering gear from the intermediate shaft or the steering column, you'd have more leverage on that shaft acting on the steering gear. Another way that manufacturers would design systems to mechanically provide better ability to steer without requiring more strength from the person would be to have a higher gear reduction. On a lot of systems, you can figure that it's going to be about 20 to 1, 20 degrees of steering wheel rotation to 1 degree of tire movement. Now you can have variable effort power steering. So by adding a hydraulic power steering system to vehicles and making it standard, for many years, enables manufacturers to design their components differently. So where manual steering is a direct effort of input to output on the steering system, a power steering system without the power assist functioning may be more difficult to steer than a manual steering vehicle would. The reason is because that fluid pressure operating at high enough of a pressure provides a significant amount of assist and helps the driver steer. So when the system is operating and functioning, that system can be designed to be even more difficult to steer than a manual if the power steering wasn't working. So when it is working, you have a better feel of the steering capabilities of the vehicle. You don't have to steer the wheel as many times, so therefore it would have a lower steering ratio. So instead of a 20-to-1, it may have a 15-to-1 or 10-to-1. These aren't specific numbers for vehicles, but it gets the idea down that a power steering system will have a lower steering gear ratio than a manual steering system might. There's a lot more to cover on this topic that the text goes into, and more that we'll do in person in lab. Until the next one, thank you.